Okay, we are going to deal with probability. Now, in order to deal with probability, we need to be familiar with certain terminology. Okay, so the terminology that we have to deal with is certain, probable, unlikely, and impossible. Now, if something is certain, you can firmly rely upon it that it will happen. And if something is probable, it means it is likely to happen. If something is unlikely, it means it's not likely to happen. And if something is impossible, it means it cannot occur at all. Now, certain is a statement that would normally be true or factual. Now, these statements cannot be argued with. Okay, then we also have probable. The probable is most likely to be true, but we have a little bit of doubt, but it is most likely to be true, which means you can argue such statements. Okay, and then you have unlikely. Now, this is likely to be false. Likely to be false. It means you can also argue such statements. Then you also have impossible. Impossible, this cannot happen. Now, this you also cannot argue with. Okay, so it can't be argued. So now let us look at the following statements. If you say the sky is blue, if the sky is blue, this statement would certainly be certain. The answer to this statement is that this is certain. The sky is indeed blue. Or the sun is yellow. This is certain. Humans can't fly. This is also certain. You cannot argue with these statements. Now, the next two statements are for probable. Now, if I say COVID-19 kills, there's a bit of doubt there because there are those who recover and so on. So it means you can argue with these statements. So it is probable. So, and then the next one, if you study hard, you will pass your exams. Now, that also can be argued, but these statements are probable, most likely to be true. Okay, then you also have the statement concerning unlikely. If you say it rains in winter, right, you can argue with that, but we normally don't expect rain in winter, depending on which part of the country you are in, or which part of the world that you are in. Then the second one would be there's a cure for coronavirus. You can also argue with this, following recent news in Madagascar and so on. Now, the last three statements are for impossible. Now, if you say tomorrow the sun will rise from the south, now definitely that is impossible. And then we also have, if I say the human blood is yellow in color, that is also impossible. The moon is square shaped. Now that is also impossible, which means when it comes to statements concerning certain and impossible, do not find yourself arguing with people over such statements. So this next part will be looking at these shapes. We have about three different shapes: a triangle, a circle, and a rectangle, right? Now, if you had this shape in a plastic bag, black plastic bag, and you are allowed to pick each out of a plastic bag without seeing, what are the chances that you might pick a circle, a triangle, or a rectangle? Okay, so I'll be showing you how to calculate that. Now, the first one, let's look at it. What are the chances of selecting a circle? Now, in order to get this, you must first figure out how many circles do we have, right? So we have 1, 2, 3, which is we have 3 circles out of how many shapes in total? The shapes that we have in total is 1, 2, 3, 4, 5, 6. So this would be 3 out of 6. So 3 divided by 6. The 3 divided by 6 would give you a 0,5. But normally when we're dealing with this, we actually expect your answers to be given in percentages. So in order to get it, you'd have your 3 divided by 6 and you multiply by 100 there. Then your answer would be 50%. So there's a 50% chance of picking out a circle. Now, what are the chances of selecting a triangle? You have how many triangles? You have 2 triangles. That would be 2 over 6. Now I said you always give it in percentages, so 2 over 6. You multiply by 100 to get a percentage. Your answer would be 33%. So there's a 33% chance of selecting a triangle. So the third one is, what are the chances of selecting a rectangle? You only have one rectangle from the shapes given. You only have one rectangle. Therefore, your chances would be 1 out of 6. You multiply by 100, remember? You multiply by your 100, then you get 16.6%, which is approximately 17%. So you have 17% chance of getting a rectangle. Okay, and the last one, what are the chances of selecting a hexagon? Now you notice from the shape, we don't have a hexagon. A hexagon is a 6-figured polygon, 6-figured side polygon. So we don't have a shape with 6 sides there. So therefore the chances of selecting a hexagon would be completely 0. So it would be a 0 out of 6 multiplied by 100, which would give you 0%. So the chances of selecting a hexagon is 0. So this is impossible. According to the terminology that we've learned, this is impossible. The 17%, this is unlikely. This would be also unlikely, the chances are low. Then this has very high chance, which is 50%. This is probable. Okay, so I'm now going to show you the tree diagram. Now the tree diagram is normally used to determine the total number of possible outcomes rather than giving one certain answer to an event. Okay, now so if a married couple wants to have children, what are the chances that their first child will be a boy, their second a girl, and their third a boy? How many possible outcomes are there? And if their firstborn is a girl, what are the chances that the second would be a girl again and the third a boy? Now you realize that you can not use a mere calculations to figure this out. So I'm going to show it you on the tree diagram and also using calculations. Then we'll also prove it on the tree diagram. So I'm going to use these 2 symbols. This one is for a male or a boy, and then this one is for female or a girl. So this would be our tree diagram, which I will later explain. Okay, so in order to figure out how many possible outcomes are there for a married couple who wants to have a baby, either be a boy or a girl, so we want to check the possible outcomes. Now this is a power, this is n to the power x. This is how we can figure it numerically. The n would represent number of outcomes, the x would represent number of events. Now the number of outcomes, in this case the child can be a boy or a girl, so it would be 2. Okay, So if we're looking at the first child, for the first child, we would have our n to the power x. Our number of outcomes will be 2. The number of events will be 1 because it will be the first try. Then it will be 2 to the power 1, which is equal to 2. And then it means we have 2 possible outcomes. I'll also show this to you on the tree diagram. Now the second one, if they were to have the second child, how many possible outcomes? It will be n to the power x, which is equals to 2 to the power 2, which is equals to 4. It means they will have 4 possible outcomes. Then for the third child, it will be n to the power x, which is 2 to the power 3, which is 8. It means they have 8 possible outcomes. So as you can see from the tree diagram, these are the parents. For the first time, for the first try, so not the first child, how many possible outcomes are there? This would be a boy, this would be a girl. So these are 2 possible outcomes. The chances are 50-50, okay? Then for the second child, it would have 1, 2, 3, 4 possible outcomes. As we have calculated in the numerical order, the second child, there would be 4 possible outcomes, and the third would be 8 possible outcomes. So from here, you can see from the tree diagram that for the first child, there were 2 possible outcomes. For the second child, it would be 1, 2, 3, 4 possible outcomes. And then for the third child, it would be 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes, as we have shown numerically there.